Good afternoon and welcome back to the Blue Talks, where we're going to continue this discussion about decarbonisation of the shipping industry, or rather, in this specific talk, we're going to look about some of the operational efficiencies. We've talked already today and yesterday about some of the ways that ship operations can be optimised, and we've recognised that that is one of the steps to meeting the 2030 goals that the IMO has stipulated. So it gives me a pleasure now to actually introduce Meteo Group and some other guests to come and talk about how weather routing and optimization actually work together in the shipping industry. It's quite a competitive industry, but there is a lot going on, and there's a lot of ship owners that are becoming more and more familiar and more aware of what can be done and becoming part of this solution. So I'm going to now hand over to Mark Struper from Meteo Group to talk about what they're doing and what the solutions that they see are. And then I'm going to invite guests up to come and talk to me a little bit about how we see ships being optimized and how we can actually make the best out of weather data. So Mark, the floor is yours.
Well, thank you everybody for making the time being here and listening to what I have to say. Let's see if the clicker works. Well, my name is Mark. After this pitch I will be right over here, so if you want to talk to me after this session, feel free. So there's a big change going on in shipping. You see, there's a lot of environment issues. There's a lot of regulations from the IMO coming in, where shipping has to deal with. And we as a weather forecasting company, we also try to make use of that opportunities to turn regulations into opportunities for shipping companies. But we're still facing an old mindset. Some parts of the industry are high-tech. Companies are investing a lot of money in new features, new software systems, new ways of working, but still, at the end, facing an old mindset and bound to certain regulations or certain ways of doing things. So the big change, what does it mean for shipping? So the regulation is changing. You've got MARPOL areas, ECA zones, whale areas. The climate is changing. Well, on an average, not that much happening, only the weather is becoming more drastic. If there's wind, there will be more wind. If it's dry, it will be drier. If it's raining, it will rain more. So it will be more extreme. And of course, we try, as a weather company, we try to cope with that. We try to innovate our systems and our models to deal with those changes. So the importance of weather in shipping. Of course, the initial idea is to keep the ship and the cargo safe. Ship is expensive, people on board are very valuable, and you're sailing with a very valuable cargo. And then you have the optimized weather routing. What is weather optimized weather routing? What's the optimum route? I have this discussion quite often with our clients. And it depends. There's no definition of what is the optimum route. The optimum route can be a fixed ETA, because if you're too late, you're facing a claim. An optimum route can be a smooth sea. Everybody saw a vessel ending up at Madeira right now because she was lashed to the deck and she went overboard. So the optimum route was a certain sea state. So it depends per vessel, per cargo. So every time you need advice from the experts, what is the optimum route? And of course, the initial idea is to save fuel, but it goes beyond saving fuel. So it's fuel saving, but it's also time saving. It's cargo saving. It can be everything. It depends on what you find important at that time, at that moment, for that particular ship, for that particular cargo. And a hot topic right now is optimum speed. If you talk to the engine manufacturers, you've got slow steaming. But what is slow steaming? You've got certain flash points that you have to take into account that you can't bypass, otherwise you use more fuel than you intentionally were aiming to save. So the optimum speed, that's a hot topic. Another one is lake N. Everybody got the fancy words of virtual arrival, a certain lake N period, but if you arrive at a certain port Saturday night, it's more expensive than arriving in port on a Monday morning. So if you have a lake N period, which can be a couple of days, there are still different cost aspects within that lake N period. So, and if we have all that information, then we can optimize even within that lake N period. Shipping, onboard team on the vessel and operations in the office. As we speak, I see too many companies still working as one company, but operating as two different teams. You've got the teams on the vessels, and you've got the operators in the office. And every team has their own KPIs, their own things they find important, and basically they work within that team. But actually, the team is the company. That should be the team, and not the vessel, the crew on board versus the operators in the office. Now they should act as one team. So that's why it's important that everybody has the same information at the same time to make certain decisions, and not having their own goals and their own KPIs. So you see improved routing, real-time decisions which lead to performance improvements. So sharing information from the ship to the office, but also from the office to the vessels. So the captain knows, okay, he understands why certain decisions are being made. And if you don't communicate that clearly, then the captain says, well, the operator is an idiot. But if he explains why he does that, then the captain also can add his knowledge, and together they can act as a team to get the best end result. And using all that information, you get a better understanding of the vessel. So you can determine which vessel is the best vessel for this particular voyage or with this particular cargo. And at the same time, the more data you get in, the more creative ideas you can project to use that information to get a better end result. So the end goal is use weather information and hindcast data and forecast data, and use all that information and combine it, and not look backwards to the performance of the vessel, but aim to use that information during the voyage so you can make certain changes. So not the blaming part after the voyage has ended, but during the voyage optimize it and be more efficient. As a weather company, in the old days, people were looking at start of sea passage, end of sea passage. But there's a whole world before it and after it. What's my optimum ETD? What are certain loading conditions I need, or discharge conditions? With certain cargoes, I need certain a dry period, for instance. But if you don't have that information, you're just standing on the deck with the best guess and facing a delay, or and you have to inform the operator again. The operator has to inform the client why there's a delay. And if you have that information in place, you can plan it. And you can see, okay, we're facing a delay. Or if we speed up certain things, we can make use of a certain weather window to do the discharging or the loading. And we're pretty big in shipping, but we're also pretty big in different areas. For example, gridding of the roads. So we take care of highways and airports, but that same information we can use for ports. Because if there's snow and ice on a normal road where you drive your car, or in a terminal, for us there's no difference. And certain ports are making already use of these products, but still there are certain ports just facing snow and rain as an act of God, and not have the precautions in place. So management of cost variables, how to manage the cost, and how to create more calculated risk approach than making assumptions. Also a hot topic in shipping is C margins. C margins, in short, is I'm planning something for next November. And I can make all the calculations, and then because it's November, I will simply add 17.5%. If you ask somebody else to make the calculation, well, in basis, he makes the same calculation. He said, well, on this one, I do 16. So if you ask 10 different people, you get 10 different results. So, and C margins is that we combine a lot of data and trying to predict a really accurate number. So if you select a certain date in the future, you can say, okay, I need 14%, because 13% I will lose money. Perhaps I can do 16, but depends on the deal. But it's more a calculated risk, so I can manage my cost upfront. And of course, flexible contracts. When we do a routing service, sometimes we see certain opportunities, and we can save 30, 40, $50,000 on that particular voyage. But we can't execute it and save that amount of money because there are certain contracts in place. They're written in stone without enough flexibility to say, well, it's fine that you save the time and save the money, and I don't care that you're 2 days late. I've got a contract in place and I'm holding you to the contract. So you can't save the money. So it's not about optimizing start of sea passage, end of sea passage. You have to optimize the entire chain. The logistics part before start of sea passage, but also after the start of sea passage. So if you're sailing to a port and you're already seeing in the forecast there's more than 40 knots of wind in Barcelona, the cranes will shut down. What's the point of sailing with 16 knots to that port, being in time, and saying, yay, I met the contract, I'm in time, and now I'm facing it 3 days delayed because the cranes are shut down. So what do you have to take care of? Have the right people at the right place. Have master mariners in place and meteorologists in place, and team up to make the best weather routing advice and the weather forecast. Not only meteorologists, but also have master mariners in place for the navigation issues. Collecting all the data and have that data analyzed and used in the whole decision making and make it available for everybody who can use that information to their benefits. And of course, we don't want to create all kind of specials for each different client, because every shipping company has its own ways. But you can't make 10 different systems. What we can do is make modules. So we try to make standard modules, and overall we can then try to make a tailored solution for that specific client using the models. So integration is also a big part. Weather routing should be combined with active systems, not two different systems. No, just let them interact. Otherwise, you're just copying information. And the technology is out there just to connect and hook up different systems to each other so they can exchange. So it's faster, more accurate, because there's less handling, and get a better end result. For us as Media Group, it means We're investing heavily in new models. We now building stuff in the cloud because the community is demanding more data, faster data at a higher accuracy. So the existing modules will become obsolete in the future if we do nothing. So we have to act and rebuild our systems, what we are currently doing, because we need more power, because Mr. Intel can't produce faster computers. So we have to expand and use more computer power. And for us, that's the way why we're moving things into the cloud, to get more power, more capacity, to render more data at a faster rate with a higher accuracy. So at the end, the idea is a total solution for the entire voyage before and beyond start of sea passage and end of sea passage. So I have some challenging statements. What is sustainable shipping? Is that maximize business and minimize the cost? Because sustainable is a bit of a marketing word. At the end, it's all about money. And a greener world in a grey reality. As I mentioned before, we're investing heavily in technology, in people, in education, and at the end, we're facing a contract which is copied and drawn up in the 50s and copied ever since until 2019. So with all the fancy systems in place, at the end, we can't fully use them because we're still bound to the old contracts. So my statement is, if we want to do it, we have to do everything. The entire voyage, but also look at the legal part and the contracts and make the contracts more flexible so both parties can make use of opportunities. And then you are a bit greener and sustainable. Well, this was my pitch and introduction to the panel. I will be around, so if you want to discuss it or share opinions, feel free to contact me.
Thank you very much, Mark. Thank you. One of the things that you've alluded to there is in terms of the mindset, and it's that's one of the topics I want to have a look at now as we move into the future of voyage optimization and how we look at weather data. So please, could I ask my three panelists to come up to the stage now? And with us is Christopher Boehmer from Klaveness, Matt Corey from Meteo Group, and Haley Van Leeuwen from GNS. Clearly, we represent the shipping operator who's using this data. GNS, I'm going to come to GNS a little bit because I think I might have to ask you to explain who GNS is. And we know who Meteo Group are. And a little bit, but I want to go into a little bit more detail about data from Meteo Group, okay? And then I'm going to ask about the data from GNS's side. And then I'm going to talk to you about how you really want the data. Because you've got ships, big bulk vessels, I believe, quite a few of them all over the world, in different seas, in different storms, and different weather opportunities, and going from A to B usually, and doing so safely. But you've got probably unique demands. So I want to talk to you a little bit about the data demands that you have and how you go about utilizing that data and how you want to use that data in front. So Matt, can I start with you, please, about Meteo Group and data? Weather data sounds to me like something, I've got an app. In fact, I've got two apps. Because I live in Sweden, I've got one from the Swedish provider, SMHI, and when I'm in Norway, I've got one from YR. I always find the one from YR is more accurate when I'm in Norway than SMHI, and when I'm in Sweden, I find the SMHI one is more accurate than the Norwegian one. So that's just me on a personal level. So from Meteo Group's perspective, data, it's not just the data, is it? It's how you interpret the data. You've got the same data as your competitors, but how you interpret that data. So let's talk a little bit about the data that you get and how you actually manage to interpret that data and give advice.
Sure, yes. I always talk about being a meteorologist as the only profession where you could be wrong 50% of your time and still have a job, right? So it is challenging being a meteorologist, mainly because there are so many data sets out there that you can choose from. And so much of the decision process from the weather industry is choosing the right data for what you're trying to apply it to. So not every application out there is created equal. They use different data sets for different solutions. Now, at Media Group, what we have in terms of our data that we're using in our products is weighted data. So we're taking various models. Yes, many of them are the same models that you find elsewhere, but we're doing verifications on those data to find out and make sure that the right data is used for the right body of water, used for the right time period. And from weather data, you always, often as you go out in time, it gets less and less accurate, right? I always used to say, anything over 3 days, you take a coin and flip it. But as you're getting more and more data in to verify your data, it's getting more and more accurate as you go forward. And the weather industry itself is also changing. New technologies are coming online all the time. And one of the newest technologies out there is called occultation, satellite occultation, which is pretty neat. It's using GPS data to go through the atmosphere, which is actually getting a reading over the oceans, which the ocean is one of the last frontiers of data collection. And that's what's fantastic for the industry. However, it's not verified. It's data, it's coming in, people are trying to make decisions on it, but how do we know it's right? So that's what I ask, is how to know it's right. So one of the things that we're looking at is getting the data from the vessels, getting verified data from the vessels, because we always used to say garbage in, garbage out. If the data coming in isn't accurate, then how do you verify that you're right? And so that's what we're looking for, is to get maximum shared data and maximum reliability out of it.
But the data you're going to get from a ship is only the data for that ship. And when you're looking at weather patterns and that, and you're giving them advice that comes back, you're needing a lot more than just data. You've got satellite data, I understand that. But when you talk about garbage out, garbage in, how do you make sure that the information that you're getting is accurate? How do you trust the data that you're being given?
It's a very good question. We say trust but verify is a common word. So we trust it, but getting information in from the mariners themselves, what was it like when you were there, looking at the new reports as they come in and saying, was this accurate? But we also, as we're tracking vessels, we get the new reports, which gives us a lot of data about it, but we have a whole team of people that we employ to go in and verify, was that data accurate? And does it make sense from the last report? And so that's how we're verifying that the vessel has traveled the distance it's gone, it's used the amount of fuel that it's claimed. It is a complicated process.
Okay, let's move over to GNS now. Starters, I need you to explain to everybody here, no, probably not everybody, but I just want to explain what GNS, or who GNS is, and what you have to do with the weather.
Okay, right, yes. So GNS is a maritime technology company. We started out as a navigation company, really. We provided navigational solutions for shipping companies, and we still do that. But what we now have is an increasingly modular and scalable infrastructure that is providing an increasing range of solutions. So, for example, we aggregate lots of data from lots of different places, and we use that data to provide our customers with an increasingly complete view of the maritime environment they're operating in. So that's both the officers on board the ships, but it's also our shore-based stakeholder groups. And it's increasingly our shore-based stakeholder groups. So, for example, they'll obviously use our data to track where the vessels are, to look at the vessel's performance against the planned route, to monitor whether or not they're going to make it to the port in the right sort of timescale. But also they're looking at sea hours data, nautical miles sailed, they're looking at asset utilization, they're looking at using that to help them to cost and budget forecast much more accurately. And what's happening is that as a result of increasing information being available, they're able to make better decisions. So we've now got 500 companies using our platform that are looking after 6,500 ships. And
but the data, going back to what Matt says, garbage in, garbage out, if you've got different routes, different sources of data, weather data, current data, other data, and that's all going to interplay with each other. Going back to what you were saying, Matt, about how you've got to verify the data, that's an awful lot of data that you might need to verify all the time, isn't it?
Yes, so so what you're getting is increasingly better quality data, absolutely. Some information sources are better than others. Some partners are better than others. we work with lots of different types of companies, and we aggregate a lot of data from lots of different sources. Some of that data shipping companies need to look at with a degree of care and moderate their decisions based on the quality of the information. But as a company ourselves, we've been collecting this data since 2015 for our own personal use, really, to help us meet our customers' requirements better. It's only really been in the last, I suppose, 7 or 8 months that we've opened it up to our customer base. What we've found is that our ability to service our customers' requirements has improved dramatically just by having that level of insight. And yes, of course, there will always be variability, there will always be variances, but having more information is definitely a good thing.
So the data that you are able to then offer your clients, and whether they're a ship operator or another kind of ocean-related industry, how do they then use data? Even, I mean, I can understand from the weather routing perspective. When I operated on ships, I got a map. Came through, and this just shows how long ago it was. I got a fax coming through of all the storms in the Pacific, for example, and me and the captain would just decide, okay, we better go that way because we think this hurricane or this storm front is going to go that way. We better move a little bit round to starboard a little bit more and just go south of it. I know it's a lot more sophisticated than that now, but my point is, though, that the interpretation of the data to actually make value of that data. And this is where I'm going to come to you now, please, because getting the data off of the ship is one thing, getting the data back, which includes weather data, etc. But what for you is the most important data? When it comes to the operational efficiency of a ship, what is the most important data that you want and you can use?
I think Mark mentioned it in his presentation as well. For us, it's about managing risk. It's as I say, we don't actually care too much about the weather models and how they are interpreted and how they are doing the analysis on it, but it's about taking decisions based on what we can expect and what we can manage on the risk side. One example is related to, okay, as what kind of speed should we do, but what kind of contract should we take? What kind of risk are we taking in the different contracts with respect to the weather? As the weather has a huge impact on our bottom line. It could be from very good to very bad, depending on how we are actually forecasting how it will be and how we are pricing our services as well. So if we can know in front that we can price the services with a C margin, as Mark mentioned, or if we know the weather in the port we are arriving to, we might do decisions that can help us to avoid losing money, because that's where we lose a lot of money today. It's about the weather in the ports, which for dry bulk it can be quite crucial, and it's about also losing a lot of days at sea where we didn't expect the weather to come.
Tell me a little bit about that. I understand the concept of putting the dry bulk vessels. You don't want to get the cargo wet. It's imperative. But how do you liaise in that circumstance? How do you liaise once you get the weather information coming through and you just go, okay, I'm going to exaggerate a little bit. It's going to be raining when we get into Oslo. We don't want to load the cargo because the cargo can't go wet. But how do you turn around to the cargo owner and just go, it's going to be wet, we don't want to go out today?
Yeah.
What kind of a discussion?
That's where we kind of have a problem with the contracts as such. As you say, the industry is not ready for that at the moment to actually take that discussion, because we have a laycan, we have obligations to be there, and if, as you say, the weather is not permitting discharging, okay, then we have to wait, and then depends on the contract who actually is paying for that time for waiting. But as you say, if you look at the whole chain there, I think it's a lot of opportunities for both the cargo owners, ship owners, and the charters to do this much more efficient and to. So
surely there's the risk to say we need to discharge this cargo because we need to get out, and we've got another client. You know, we're going to load another cargo. It's not our. I'm not saying you think like this, but you could say it's not our problem. It's now your cargo. You know, it's on the port side. It's your problem that it's raining. But you want to have a much more integrated discussion with the cargo owner, with everybody, to make sure that there is that flexibility, that you don't have to offload all the cargo. It gets damaged because of weather.
Yeah, and then of course, if everybody have the same access to the data and also, of course, can trust it, then of course we can maybe take that decision up front and to agree with them, and of course maybe also share the benefit of doing so as well, because that is also the problem, that you don't have actually an incentive to do so, because you are following your contract and they are following their contract, and that's how it is. But I think it's a lot of opportunities there to be more interconnected with and using weather as one source of planning much better on this side.
Do you find that when you actually signed contracts with the shippers, that you're able to have more flexibility when it comes to like a bill of lading and the contracts that you sign? Are they willing to talk about data-related clauses in the contracts that say, look, let's get this data, let's assess the data, there's a longer period of laycan, there's an opportunity to actually have flexibility?
I think it's more and more, but traditionally has not been the case. More and more, I think they are open to discuss these things as we see the upside for it. But I think still we are very early on that journey to actually utilizing the source of the weather, and we are open to do that as well. But then again, you have to have a counterpart which actually do the same, and you have to trust the data coming in. Okay, so I think that's the key here, to trust the data, and that's this department.
Yeah. when I was at sea, okay, it was a long time ago, and I used to enjoy that skill of navigation. How do the crews of today take on board all of the data that's been given to them? Because you have mariners and meteorologists in one room, am I right?
Yes.
So you sit there, ex-mariners and meteorologists working together, doing the thing that I liked to do when I was on the ship. So the captains and the navigating officer on the ship no longer have to do it. Do they really enjoy that?
I think in general they appreciate the help, because it's about making their life easier, and they appreciate to have this guidance on where to go to optimize. As Mark said, it could be also optimizing for if you need cargo hold cleaning on the way, or if you do maintenance on the way. Of course, it can help you to plan for that as well. But I think in general it's not difficult to supply them with these tools, and they, of course, they're always their decision, and we will never question their decisions. And but at least it's a tool for them to be able to navigate in the most efficient way.
And the data that comes on and goes off, and actually perhaps this is a better question for you, Hayley, because when you're actually taking that data and interpreting that data, and you integrate weather data with other sources of data, other things really, that aren't necessarily weather related. What sort of things do you find that how can weather data influence other data, I guess is what I'm saying. So, I mean, we touched on the port side of things, but on an operational perspective, when you get weather, do you think, and you alluded to sort of like cargo tank cleaning, etc., but how does that relate to other aspects? Because I guess there must be how weather will impact other operational things that people possibly don't think about.
No, I think that's right. I really do think today on board vessels, the weather is primarily being used for route optimization. That's its primary purpose, and certainly within most platforms on board, that's where we're at. The algorithms are running in the background. You're deciding when you want to leave port, when you want to arrive, what your key factors are, whether it's arrival time or it's fuel consumption or whatever it is, and you're building that in, and then you're getting the optimum route for your passage. And then as a navigator, you are sailing that route based on the information, and that's obviously taking into account what the hydrography is like, what the tides are like, and also what the weather is like. And just at that level, it's an incredibly powerful tool compared to probably when you were sailing, Craig. And so that's moved on enormously. I think that once you start to talk about the risk management side of things, you're really moving into the domain of the shore-based stakeholder. You know, when is going to be the best time for something to happen? When are we going to do that particular cleaning? When are we going to make a plan for dry docking? What are we going to do when are we going to do those things, and what are our factors? And they're not really the decisions the crew's making. They're the decisions that the executives are making in the office. And so what we're finding is that bringing that data back ashore, making it more usable, making it more of a management tool rather than navigating tool is becoming increasingly important. And it started mainly in marine departments, but now it's spreading to lots of other departments. Would you agree with that, Christoph?
Yeah, I fully agree. That's,
Yeah.
as I say, now it's much more focus on it, and it's as you say, you started to see where other areas you can use, as you say, this information, and for especially as for the planning part of it, and also for us to look at longer contracts. Okay, how should we price them, and how should we prepare for them?
Yeah.
Should we have cargoes lifted during summertime to be more efficient on that, and try to get away from the worst months, or so it can be a lot of different decisions we can base on the knowledge that we receive on the weather side.
Yeah, navigation, I think, used to be one of those almost stovepipe processes that happened on board. It was something that had to happen. It was the process of getting the vessel from A to B. It no longer is that. It's navigation is something that happens in the wider context of everything else that's going on in terms of, the commercial viability of that particular voyage.
That raises the question with you, Matt, about who your clients are. It's not just the ship operator then.
No, I was going to chime in. Much of the weather industry is moving away from, tomorrow it's going to be a southwest, 15 knots with a following sea. It's more of an impact base. So yes, you have that data coming in, but what does it mean to me?
Yeah.
And as Mark put in terms of the complete value chain, it's today it's almost commonplace now. Is here's the weather data. Here's the confidence factor about it, and if it's a certain level, this is what we think is going to happen, all the way from in the port logistics, where you are, to the port where you're going, but also it's about updates, right? You can't just take one piece and go. You have to constantly update each time through that voyage, and the people getting those updates are both onshore and in the vessel, and they need to be able to talk to each other and make sure, but it's important to have that sync together so that the impact from these is agreement between both sides of
Just from that perspective then, when you talk about weather data, because these are some of the things, everybody talks about data these days, and it's used in a rather nebulous, in my view, sometimes used in a too nebulous a way, because, one person's data can be in another person's just irrelevance. So when you talk about data, you talk about temperature, wind, you talk about pressure, you talk about cloud, you talk about weather fronts. Am I missing something?
Yes. There's sample data, there's predicted data, there's data that comes out of the global models, and we do run our own models as well above that. But there's also the interaction between ocean and atmosphere, right? A lot of the weather companies will focus on one or the other, but where that coupling is really critical for our industry, and so that's one of the things that we're deep diving into is getting that more accurate to be able to put it out. I was involved in a program for NOAA that was called the National Mesonet, and the whole focus, which is kind of relevant to what we're talking about, the whole focus of the National Mesonet was there's too much data coming in, and we have a challenge with communications and getting the data in, but the challenge of the National Mesonet, we have too much data coming in from IoT devices, from personal weather stations, and all these things. How do you trust it? How do you know? And so the focus of that was on metadata. Yes, show me the data that's coming in, but I want to know everything about that data. How was it collected? What sensor was used? When was it last calibrated? Where is it located on the vessel? And the idea is okay, now we can trust that piece of data. Now, what's the next piece of data coming in? So it was more or less collecting data about the data. and that helped verification, it helped doing the models, it would help doing the post-voyage analysis. It would just move everything up to that next level if we had such a metadata type collection.
And that allowed you to create standards as well, I imagine, because without standards, you could be getting data from different sources, which is in Fahrenheit and centigrade. It can be different types of wind speed. It can be different types of levels of data. So you need to create standards. And this was something, actually, I remember when I was doing things with UKHO and we were talking about standards, when everything went digital with the charts, they had to completely assess what they meant by the datum for the charts for zero sea height. because there were different datums around the world. So when everybody started to digitalize the charts, they realized that first of all they had to create a standard there. Otherwise there was going to be some big problems. You know, theoretically you'd just be going down 10 meters as you sailed across the sea. So do you find that you're now beyond that point now when it comes to the standards and the metadata? Have we got weather and also, I guess, climate discussions as well, to a point where we've got the good base data, where we've got the metadata, we understand how it's going to be used, and we can actually start doing it now? I don't mean climate from the perspective of climate change. I mean climate as in, as Mark alluded to, in November it's going to be cold, it's going to snow. We don't necessarily want to start offloading or loading in that port then, we need to get it done before. That kind of seasonal climate. So are we there with the accuracy for that?
As I alluded to, fit for purpose is a good word, right? So various levels of data, you could make decisions off of its current state. Now, as we try to get more into fine-tuning the vessel optimization for getting to the port to port versus start of sea passage, end of passage, right? We're going to need to have more fine-tuned data than we have now in order to get to that level where everybody wants to get to. But in terms of making just general, I call it data mining decisions, we do have a very good database throughout the industry to be able to make those good decisions, but we certainly can do better.
And actually, I'm going to go to Christopher here, please, because it was something that you mentioned, and I'm not sure if Mark mentioned it, but it always pops up, the noon report. Do you still do a noon report?
Yeah, we do. But I think that depends a little bit, because we are a company doing both the chartered vessels and our own vessels. But for our chartered vessels, that's the only thing we have from the vessels. That's the manual reported noon reports. So of course, in our system, we don't actually kind of trust the reported weather from the ships. So that's where we're using these guys to actually assess what kind of weather has the vessel experienced during the voyage.
Because I guess with the noon report, you're still, maybe not, you're still asking a sailor to look out the window and do that and say, force 5, southwest, and they might be off by...
And then again, they are looking at the charter party when they're doing it, so they know what's the limit for good and bad weather. So I think that is just reported for information, but it still depends on the manual noon reports, both for the consumption side, but also for all the other parameters. For our own vessels, it's a little bit different. Then we collect much more information ourselves, and then we also have weather data coming in, as at least the wind and the directions. But also now we're looking at, as I say, motion detection and how the vessel actually is moving with the weather as well. And I think that's where we are discussing as well, because that's the most important thing.
Because they were touching on not so much the, well, it's part of the weather, but the sea state and the...
It's about how the vessel reacts to the weather, because that's the most important thing. Because different vessels, they are able to cope with different type of weather. So I think more and more we will come to that, and hopefully soon we will have more automatic reporting as well from all ships. But today it's, at least in our segment, very, very manual.
Why did you laugh when I mentioned noon reports?
Oh, it's just one of those anachronisms, really, isn't it? Because it does come up. It always comes up, and it's because it's that one piece of communication between the parties, and no charter ever believes it, and there's this sense of it not being a version of the right version of the truth. And what's happening is that increasingly, as you're layering up lots of different types of information from different sources, of course, you're introducing lots more transparency, and it's becoming a lot harder to hide behind the noon report. So I think that's helping everybody, actually. Although I think some shipping companies are probably a little uncomfortable with it still, I think ultimately it will help a lot.
Why do you with the vessels you charter, you say you're doing noon reports for them, but not with your own vessels? Why is it the chartered vessels still do noon reports? Why can't they be part of a standard reporting system?
If there were a standard,
weather conditions.
Yeah. If there was a standard available, which you might use, as you say, as a part of the contract, I think that might work as well. But still today we are in Windows 7 in many vessels. They don't have anything, more or less. They are really not able to communicate. They don't have any bandwidth. They're not from the vessel. So we are actually relying on sometimes just Inmarsat communication, simple standard reporting. But I think, of course, that will change over the years to come. But still, we are there now. It's very old-fashioned way of doing it. It has been there, as Mark mentioned, for decades.
Yeah.
It's still there. The contracts are more or less based on it. So.
But that must make it very difficult when it comes to fleet-wide operations, because you've got analog ships and digital ships. You've got ships that are sophisticated, they've got a lot of capabilities to receive data, respond to data, transmit data, and then you've got the ships that are, as you say, they haven't got a lot of bandwidth, they may receive a couple of faxes every now and then, and it's up to the captain to decide whether he's going to swing to starboard to avoid that storm on the facsimile. That must be frustrating but good news for you, because it means you've got a good client base to target for, but frustrating that you see such basic operational context still. How do you look at this industry and sort of benchmark the standard, the norm? Because Mark sort of alluded to this, the changes, but where would you see those changes? Are we still sort of analog? Are we 10% digital? Or, I'm not going to say we're 100% because we're not, obviously, but...
I ask that question every day, right? It's like, you know, we're stuck in the technology, and I know why we're there, but I think the technology is improving, communications are improving, more and more satellites are getting launched all the time, and therefore prices are coming down of satellite communications, and so I hope things go forward with getting more and more communications to and from the vessels, which will help everything. Getting this data off of the vessels in real time would be just fantastic. But right now we're still stuck with Noon reports, and you know, getting that Noon report standardized, or are able to help those Noon reports with better communications, better technologies. In the short term will help, but longer term, we should be able to do more than Noon reports. We should be able to have regular updates. We should be able to have standards on the vessels. Fuel, for example. What is your fuel state? That is quite variable as we come in for Noon reports. If we can have some standard in that to be able to say this is what it is, that would help a lot in terms of post-voyage analysis and what you're doing. So it is a good question.
How do you see the data? This is just as we come to a close here. How do you see weather data improving? Do you think there's... Actually, let me go back 2 steps here, because yesterday we had one of the senior administrators from NOAA on the stage, and he was talking about data, oceanographic data, and the need to collect data. And he alluded to weather data, not just the weather at ground level, at sea level, but altitude weather and oceanographic temperatures, the way the ocean temperatures dictate where the storms are going to go. So in terms of the weather data that you can collect, and you in the future will collect, is there a great difference between what you're doing now and where you see the capabilities in 10 years' time in terms of the predictive capabilities that the systems can actually do, and that you can then offer operators, both ship operators and other operators in the ocean space?
Yes. A lot of this comes back to the global models. You have the global models, which, you know, the big ones you see over there, and the NOAA models and others that are being employed. They all use about the same inputs, and from a meteorological modeling perspective, surface data is, it's okay, but it's the upper level data that is the key. That's why that radio occultation was such a breakthrough. So that technology is going to continue to go forward. So the global models, which all the other fine-grained models are based on, will progressively go for everybody's sake. But to do that, as I said, it's garbage in, garbage out. How do you know you're right? So getting more observations from the surface, more buoys, more current observations, more wave observations will help verify where the models are right and where they're wrong. And the ocean is dictating what happens on the lands, right? Most of our surface is ocean. And so it's really frustrating from a meteorological point of view that it's not sampled more than it is. So I totally agree with that NOAA person that getting more observations, focusing on the oceans is where we as a meteorological community need to work in order to help everybody. And that's what we're focused on too.
I'm going to offer some final. We've got a couple of minutes spare. Does anybody have any questions or points that they would like to ask? If not, I'm going to ask you for some final thoughts then. And I'll start with you, Hayley, about your thoughts about data accuracy and use.
I think I'd say it's improved hugely. Where we were 5 years ago was nowhere compared to where we are today. And I think the rate of change is accelerating. And the data we have now is becoming really quite valuable. Shipping companies that are using it are really starting to see the benefits. I'm sure that Christopher would agree. And it's starting to fundamentally change how decisions are made. So shipping companies that aren't embracing data and data analytics, and in particular things like weather information in their operations, are probably really missing out.
And from Klaveness' point of view, I know there's Klaveness Digital, and it's a sort of breakaway company from Klaveness now, and it's a kind of separate entity in a way. But from the ship, I'm thinking here more from the ship operational side rather than your technology division. But from your perspective, in terms of the the data applications that you're getting to use on the ships and the services you're then able to give the ships. I know there's a difference, as we talked about, between the chartered vessels and your own vessels. There's two questions to that then. Are the chartered vessels eventually going to get better to be more aligned with what you've got operationally? And how do you see your own operational context, shoreside, supporting the operations ashore? Because Mark alluded to two distinct pools of the workforce, the ones on the ships and the ones on the shore.
Yeah, to try to answer your first question regarding chartered vessels, I think we, as we put on the chartering hat, I think we have to provide incentives to the ship owners. Why should they give us more data? Because they are very protective on what they're giving us. So if we can provide them in some kind of incentives, okay, they have an upside of sharing more data, so we can optimize the vessel and the voyages more, then they will get a part of it. Because today they are more or less no upside. They are punished if kind of they're not performing as they have promised. They will get a claim or similar. So I think today it's no incentives for the ship owners to share anything because they are scared that we will use it against them. So I think some kind of incentives there, and it might also help if we get some kind of standard to actually how could it be? What should be a standard way of instrumentation and also how to...
But hasn't there been that already? Hasn't there been some moves? Isn't there an ISO standard on some of the performance-related conditions?
There is this ISO standard for ship performance, hull performance coming, and I think that is a good start. But then again, that's kind of a voluntary thing. I think we need some kind of regulations, and I think we will see that now with the mandatory reporting as MRV and DCS reporting coming now, and the IMO may also force, as you say, a minimum set of instrumentation and calibration for those that will be available, hopefully soon. For the last questions, that was...
It's related
remind me on the second question?
Well, it's about, you've got your shore-based, Mark alluded to shore-based operations and your shipboard operations, and the data, how you can use the data shoreside. I know there's a lot of ship managers and ship operators that have got their own operational centres now and digital centres, and they call them fancy sort of digital centres.
We of course have ideas and plans for something similar on a kind of operational center which can integrate all these things together. But that will be most for our own tonnage, which we kind of have full control of ourselves, both on the technical side and the commercial and operational side. For the charter side, it will be something similar, but then of course we only have the commercial and operational control of the vessel. We don't know anything about the technical side. So I think, of course, this is the way to go, and we have for the chartered vessels a longer way to go than for our own vessels there.
Good. And final word then with you, Matt, on the future of weather reporting and routing, or weather analysis here. One of the comments, going back to one of the comments that Mark alluded to, was a lot to do with weather patterns and disruptive weather. How we get more storms. It might be called global warming, but it's actually a lot more disruptive weather, making it surely more critical to get a good weather picture.
Yes, yes. And the irony is that one of the reasons why there's many reasons why there's debate about climate change, but from the scientific side, one of the reasons is there's inconsistent data. There's inconsistent standards, even within the weather sampling. So you can take some data that was sampled a while ago, and then you can say, oh, that sensor was bad, or that was there. So it puts that level of uncertainty in. And then we're in this debate about, is there climate change or not? Is it global warming or not? But looking at, just science, what's happening? Not necessarily more storms, more intense storms. You're going to have, with differences in currents, differences in sea surface temperatures, differences as things gradually warm up, those are the cyclogenesis zones where the stronger storms will be generated. And so even more reason to get standardized data, especially in our industry, because how do you know if it's making a difference? Got to get it in. You got to get that baseline covered so that, in 2 years, 5 years, 10 years, 20 years down the line, you could say, yes, there was a trend, and it's not just in the noise of trying to figure out what your standards were and figuring out quality control. So that's how I say. And to address your point, Christopher, I agree. It's a matter of trust. We have to be able to show that by providing this data and in a standardized format, this is why we're asking you to do this. It's education. This is why we want you to do this. As a community, we will all benefit from this. And that's analysis and presentation that I think is needed.
Good. Thank you very much. Christopher, Matt, and Hayley, thank you very much. Thank you. And in about 15 or 20 minutes, we're going to carry on this theme about efficiency by looking at biofouling, where we are looking at how hulls can be maintained, cleaned, developed, and what the future is of biofouling. And I alluded earlier today about one of two biopharma companies, and one of the solutions is a biotech company that was here 2 years ago. Thank you. So, ladies and gentlemen, thank you very much.